All right, for algebra, we are starting module 8, which is polynomials. So this is something we haven't talked about before, but basically it's just expressions. So it might be like 3x squared plus 5x, or negative 6x to the fourth plus 11x to the fourth. So the whole reason in chapter 7 we learned about exponents is because we're going to continue using them into chapter 8 with our polynomial expressions. So we're going to start with a monomial. This should have been copied on your papers in color, which would have showed you this is highlighted, but that's okay. A monomial is a number, a variable, or a product of a real number and one or more variables. So here are some examples. It could be just the number 18. It could be just the variable z. Or it could be one whole term, negative 4x squared. This is a monomial because it's only one term. I don't know if you guys can think of other words that start with the prefix mono, like if you ever gave a monologue, it'd be one person talking. Things that start with a mono mean the number 1. So it's one number or one variable or one term. Here's also one term, 2.5x y to the third. That's one term. The fraction a over 3 is one term. So these are all monomials. Okay, anytime you use more than one, they're all considered polynomials, but there are specific names for some of those polynomials too. Like I said, these are each monomials, and we're going to look at them as far as for today, for the start of this lesson, as the degree of what monomial it is. So the degree is the sum of the exponents. Sum means add, so we're going to add up all the exponents and see how many total exponents there are, and that's going to be its degree. We'll come back to this last sentence here in a second when we get down to example 3, or C. So what is the degree of each monomial? 5x. 5x, the exponent on the x has a hidden invisible 1, so we're looking for exponents to classify its degree, so that means the degree is 1. Because it'd be a hidden invisible 1 on the x. So 1. So first degree. On B, this is going to be a 5th degree, a degree of 5. And the reason is because this exponent is 3, this exponent is 2, and again we're looking for the sum of the exponents, which means add them all up. And 3 plus 2 is 5. This one is what I wanted to refer back to this last sentence. The degree of a non-zero constant is 0. So if it's a plain old constant number, not a variable, not any exponents, it's just a number, the degree is going to be 0. It would be the same as having an x to the 0 multiplied by that 4, and we all know that an x to the 0 would cancel out because it would be equal to 1, and 4 times 1 is just 4, so that's why we want to throw a degree of 0 on it. Okay, so let's try these. 8xy. Remember, the x has a hidden invisible 1 and the y also has a hidden invisible 1. So when you add that up, 1 plus 1 is 2. So the degree is 2. Okay, this second one, we've got a 4 and a hidden invisible 1. 4 plus 1 is 5. All right, here's our just constant, and a constant with no variable has a 0 degree. D, 6a has a 1, B has a 3, and C has a hidden invisible 1. So we're going to add those all up. 1 plus 3 plus 1 is 5. Okay, and then let's add all these up. 5, 2, and another hidden invisible 1. 5 plus 2 plus 1 is 8. So these are the degrees. Okay, now I'm going to have you add like terms. So when you add monomials, you can add them if their terms are like. So if we have an x squared, it can be combined with other x squareds. So in previous units, we learned that multiplying exponents would change the number that the exponent is, but if we're just adding, the only thing that changes is the coefficient in front of it, and that just means we have 3 of this particular. Don't even look at it as x squared, look at it as cats if that's what you want. And since this is x squared and this is x squared, they would both be cats. So you have 3 cats plus 5 cats equals 8 cats. So the exponent does not change. This is just its label, kind of. The coefficient, which is the number out front, is the only thing that changes. Over here, I'm glad they have an example like this because it's 4x to the third y. Remember, x to the third y is just the label like dogs. So you have 4 minus, there's no coefficient. So the coefficient, if there is none, is a hidden invisible 1. 4x to the third y minus 1x to the third y would be 3x to the third y. So you don't change the label, you just change the coefficient that is being subtracted. Okay, so let's try a few of these. And remember, they have to be the same. You can't take an x to the fourth and a y to the fourth. You can't add cats plus dogs and have one number. So you have to make sure they are like terms. So negative 6x to the fourth plus 11x to the fourth would be 5x to the fourth. Remember, you're always encouraged to use your calculator. Negatives are kind of hard. 2x squared y to the fourth minus 7x squared y to the fourth would be negative 5x squared y to the fourth. Again, I'm not doing anything different with the exponents or the variables, only the coefficients, which are the numbers, the big number out front. 8a squared b plus nothing a squared b. But if it actually was nothing, if it was a 0, it wouldn't even be there at all. So because it's here, we know it has a hidden invisible 1. So that would be 9a squared b. All right, again, you've got a little 1 there that's not there, but you know it's there. 1 minus 9 is negative 8. X to the third is the like term that we combined. Okay, we're going to go on to the next page, and I'm going to refer back to this one, but the other thing we're learning today besides degrees is what these are actually called. So we know what the degree is, but we can name them. We can name the polynomial based on its degree or the number of monomials that it contains. For example, if it's just a constant, it has a degree of 0. We already talked about that. It is just a constant. It's not a variable or anything. It has one term because it's just one number that's there. And so it would be considered a monomial. 5x plus 9 is a binomial. Think of things that start with the prefix bi, like bicycle. Those have 2 wheels. So the prefix bi means 2, and as you can see, we have a 5x and a 9, and they're being added together. They're separated by a plus sign, so that means there are 2 separate terms. So this is a monomial above it and a binomial right here. Okay, if it has a first degree, which again means an exponent has a degree of 1, that would be considered a linear. That's the name for it. It's a linear. If we were to draw this out on a graph, it would be a straight line. Okay, moving on to this one. Our first term is what tells us the degree, and this degree is 2. I don't want to add this one to it and call it a third degree. You only look at the number of the degrees in the first term. So this is a 2, so the degree is 2. It is separated out into 3 different terms, which makes it a trinomial. Think of things that start with the tri, like tricycle has 3 wheels, triangle has 3 vertices. So a trinomial has 3 terms separated by adding or subtracting. Now, what makes it quadratic is that it's a second degree. So anything that goes something to the second power in that first term only is considered quadratic. We'll get into that more in chapter 9. All right, 2x to the third, if the 3 is what the degree is, it's considered cubic. There's still just one term here. See, we're not adding or subtracting it to anything, so there's just one term, which makes it a monomial. All right, here is a trinomial, separated by subtracting and adding 3 different terms. See, trinomial. But the degree is the 4th because the first term has an exponent of 4. Okay, let's try a few of these on the next page. So, we're first going to talk about putting these terms in standard form. Standard form means the biggest exponent comes first, and then the next biggest, and then the next biggest, and then the next biggest, and then finally the constant, if there is one, would come last. It has lower priority. So right here, we have a 1 on this exponent, and we have a 2 on this one. So since 2 is bigger, this term should actually go first. So you place it in standard form, which means the biggest exponents come first, followed by the next biggest, and if there were more, they would keep going until you get to just the plain old constant if you had one that would be last. So we placed them in order. This one was already done for you. 4x squared came first and then plus 3x. It is a binomial because there are two parts, and it's called quadratic because the exponent that names its degree is a 2. And if you forget that, we're going to repeat it a lot. That's not a big deal. But also, you've got this chart down here. All right. Part B, which is also done for you, has been rearranged. The 3 is the exponent that's the biggest, so they moved that to the front. These two doesn't really matter. They both are just an x. So I would actually have combined that. Actually, it looks like they did. So any like terms that you have, go ahead and combine. So 4x plus 7x is actually 11x. And then the minus 1 has the lowest level of priority, so it's going to be written last. So we're not really doing much math. We're just rearranging it into standard form, which puts it in order of priority of biggest exponent, then next biggest, and we combine them if they are like terms, and then the constant, if you have one, is last. It's cubic because the first exponent is a 3, and it is a trinomial because there are 3 terms. All right, let's try some of these. We're going to write it first in standard form, so let's rearrange each of these 3 terms into the best order, into standard form. So biggest exponent is the 8x squared, so you're going to write that first. I sometimes cross them off as I go just so that I'm not confused by what I've already used and what I haven't. And then the 2x has a higher priority than the minus 3. That's a positive 2x, so I want to separate it by putting a plus in between and then bring down your minus 3. So now it's in standard form. Oh, I'll cross them out as I go. Now it's in standard form, and now I'm going to write based on its degree. I know it's a second power, so that means it is quadratic. And I know that there are 3 terms, which makes it a trinomial. Okay. The next one, let's put it in standard form. So the 5x squared is going to come first. The minus 2x is going to be next, and then that's a positive 1, so I'm going to make it a plus 1. And once again, it's going to be a quadratic. I'm going to abbreviate this so I don't run out of room. And 3 different terms makes it a trinomial. All right. Last one, the one with the variable has higher priority than just the constant, so the 3z is going to come first, and then the minus 2. This is a hidden invisible 1 exponent, so that's going to make it linear. And there are 2 terms here, so that would make it a binomial. All right, now we're going to move on to adding, which is just combining like terms. I mean, we actually did this right here. And we've done this earlier on in the year too. And you guys did it in 7th grade too. So these are not hard. I would have stopped because it's already been a big lesson, but you guys can do this. 5x squared plus a 15x squared. Those are like terms. Remember I used the term cats earlier, or dogs, or whatever. If this has an x squared and this has an x squared, you don't change the power. You change the coefficient, which is the number in front. So 5 plus 15 is 20x squared. And then you've got a 3 plus a 2, which is positive 5, so I'm going to put plus 5. All right, and it says make sure each answer is written in standard form, but I like to pick out the one that has the highest priority first so that then it already puts it in standard form for us. So that one's already in standard form. All right, so let's look for the biggest exponent in this, all this stuff. So I have an exponent of 4, and that's the only one. So you can't combine it with this one that has a 3, or this one that just has a g, or this one that's just a constant. This is not a like term with anything else. So I'm just going to leave it 2g to the 4th. And I'm going to cross it off just to show I've already done it. Okay, the next one, the next highest level of priority, writing it in standard form, would be the 3rd power. So that's minus g to the 3rd. So minus g to the 3rd. All right, my next level of priority would be I'm noticing these are the same. So these are like terms. So I'm going to go ahead and combine them. That's a negative, be sure the symbol in front of it goes with it, negative 3g plus 12g. Again, use your calculator if you're not sure. negative 3 plus 12 is 9. So we have positive 9g. And if it's positive, you put a plus. And then now I've used that one. And my last thing I have left is a plus 9 here. So that's all there is to it. All right, sometimes you might see it written like this, so vertically. And as long as the like terms are lined up, you can just go ahead and add the coefficients, which is the number in front. So 6 plus 3 is 9x squared. 7 plus 1 is 8, and it's positive 8, so plus 8. All right. Oh, this is a you try, so this is a good time to push pause on the video and try 4, 5, and maybe 6, but there's a little star by it because it's a little tricky. So at least try 4 and 5, and then push play on the video and see if you did it right. All right, I'm going to go through these super quick because you've probably already done it. So this would be 7k squared, and that is a hidden invisible 1, so it would be plus 2k, and that would be minus 4. All right. Number 6, they're written horizontally, but you can still search for like terms. There is no other like term to the third power, so it's going to stay by itself. The squareds are like terms, so 7 and plus 8. 7 plus 8 is 15, so plus 15z squared. And now I'm going to cross them off. The next level of priority would be this negative 4 and negative 6. Negative 4 plus negative 6 is negative 10. And now I've used those. And then last we've got this minus 5, so that would be it. The reason that number 6 has a star by it is because somebody put these in not alphabetic order. Earlier in a different chapter, I told you guys that anytime you have variables, they really should be in alphabetic order. A, then B squared. B, then A, it really should look like this. A to the third, B. So what happened was, it looks like this is not a like term with anything, but when I get it in alphabetic order, it actually is a like term with this one. We have a 1, a to the third b, plus a 4, a to the third b. So 1 a to the third b and 4 a to the third b is actually 5 a to the third b, and now I've used those. And then I would go ab squared minus ab squared. If you have 1 ab squared and minus 1 ab squared, you have 0. So those actually are going to cancel out. And lastly, I have this that I haven't used, minus 5ab. All right, last new thing for today. Sorry, I know this is a big lesson. I hope you guys have watched it carefully or have rewound the video or come back to it if you're questioning. But subtracting is hard. Okay, so pay close attention to this last section. Subtracting is not just as simple as combining like terms like we did with adding. When you are subtracting, this minus is actually a negative hidden invisible 1 that's going to get distributed to all of the terms in this second set of parentheses. So this is actually a negative 7x cubed. This is actually a minus or a negative, I don't know why I put 7, 5x squared. And this is actually a positive 12 now, because a negative times a negative is positive. So it doesn't mess with the first set of parentheses. These are all fine, but it's like the negative hidden invisible 1 is here, and it goes to all 3 terms, which changes nothing except the symbol in front. So anytime I see a subtraction problem, I stop and I rewrite each individual term below it. And then I do what I did up here. I add the polynomials, because now you can combine their like terms, now that you know what symbol is truly in front of it. So I have a 1x to the third minus a 7x to the third, which is negative 6x to the third. Then I have a negative 3x squared minus 5 more x squareds, which is negative 8x squared. And then lastly, not lastly, these are 2 different terms. So I have a plus 5x and I have a plus 12. So that was a big one, but I really want you to see that negative actually changes all the symbols. All right, so knowing that, I want you to change all the symbols in front of this set of parentheses. So that's like going to now be negative 4m squared. This is now going to be negative m. You can put a 1 in front of it if that helps you. And this is now going to be a plus 12. And then I would almost just scribble all this out. Once we change all the symbols, I don't want them to confuse you. Now we can add them to get the like terms. So we have negative 4m to the third and negative 4, nope, this one's squared. That is not a like term with this one, so we're going to have to leave these separated. So negative 4m to the third is its own. Negative 4m squared would go next, it's its own. Negative 1m minus another 1m, minus 1m plus minus 1m is minus 2m. So I can cross those off. And then 9 plus 12 is 21, positive 21. So you can put plus 21. All right, this is a good time to stop the video and do the you try, and then push play and see if you got it right. All right, if you don't have it written horizontally like these are to know to distribute, you might have it written vertically like this. Don't let it confuse you. It's not just 6 minus 4, it's also minus 9. So I would still make sure you realize that's actually a negative 4x to the third, and that is now a negative 9. So this would be 2x to the third when you subtract, but 17 minus 9, not 17 plus 9. So this would be positive 8. All right, distribute that negative. That's minus 6y to the third minus 4 and plus 6y squared. So now I'm going to combine my like terms by adding. 1y to the third minus 6y to the third is negative 5y to the third. I use those. Squared and squared, these are the two next like terms. Negative 4y to the squared plus 6y to the squared is positive 2y squared. And then these are like terms. Negative 2 and minus 4 more is negative 6. Oops, didn't quite get that on there. That's okay. All right, again, distribute. Negative times negative is going to make that now a positive 5r squared. That's going to make it a minus 1r, or just r, and minus 8. So now I'm going to add to combine like terms now that I've distributed that negative. So this one's to the third and this one's squared, so they're not like terms, so don't combine them. Leave this one separate. Leave this one separate. That's a positive 5r squared now, so put a plus. These two are like terms. 2r minus 1r is just positive 1r, so just plus r. And then negative 1 minus 8 is negative 9. Use your calculator if you're not sure.